Hello everyone. So we're going to have a practice about arithmetic sequence and series and geometric sequence and series. So let's begin. So in the first problem, we are asked to find the missing term of the given sequence. So we have a given sequence, 5, 8, 11, 14, and 17. This one is the missing term. So how can we find the missing term here? So first, you need to observe the sequence and its pattern. So this one, we have 5. Then the next term is 8. How did we get 8 if the previous term is 5? So we get 8 by simply adding 5 by 3. So 5 plus 3, 8, right? Okay. Now, how about this one? We got 11 as the third term. So how did we get 11 if the previous term is 8? We get 11 by adding 3 to the previous term, which is 8. So 8 plus 3 is 11. So now, let's proceed to the next term. Let's try to add 11 by 3. 11 plus 3 is 14. That's it. Now, let's add 14 by 3. 14 plus 3, 17, right? Now, lastly, 17 plus 3, 20. Okay, that's it. That is your final answer. That is your answer. So see, all you need to do is to think and analyze. Okay, you need to think critically. Okay, or if you want, you can just use formula. Okay, since as you can see, we have like 3, 3, 3, and 3 here, right? And we use it to add it to the previous term just to get the next term, right? So your 3 is your common difference because you use that to add to the previous term just to get the missing term or the next term, right? So we can use the formula of a sub n is equal to a sub 1 plus quantity n minus 1 times b. Okay? Now, let's substitute. So first and foremost, we need to locate where is the missing term. So this is the first term, second, third, fourth, fifth, and sixth. So since this is your sixth term, therefore, your n is equal to 6. So you have a sub, wait, hold on. So you have a sub 6 is equal to your a sub 1. Your a sub 1 here is the first term, which is your 5. So this is 5. Plus your n again is 6 minus 1. Then your d is 3. So there we go. So a sub 6 is equal to 5 plus. So 6 minus 1 is 5. Then times 3. So you will have 5 plus 5 times 3 is, wait, hold on. 5 plus 5 times 3 is 15. And then let's add them together. 5 plus 15 is 20. So this is your answer. So see, that's it. All right. So let's proceed to the next term. What will be the 20th term if the given sequence is negative 2, 1, 4, 7, 10, 13, 16, and yada yada? So if you see this dot, okay, if you see this dot, okay, it means there are still more, what? There are still more terms, okay? There's no ending or stopping of this sequence. Hence, this is an infinite sequence. Okay, this is an infinite sequence because it's not stopping. Okay? Now, as you can see, we're asking to find a 20th term. But we have only given like 1, 2, 3, 4, 5, 6, and 7 terms only. But we are asked to find a 20th term. So how can we find the 20th term? So, again, observe the sequence. We have 2, 1, 4, 7. So if we have negative 2 as your first term, how did we get 1? We simply get 1 by what? Adding the previous term by 3. So negative 2 plus 3 is 1. All right? So if I'm going to have 1 and the next term is 4, how did I get 4? So I simply add 3 by 1. So 1 plus 3 is 4. Now let's do it here as well for the 7. So how did I get 7 if the previous term is 4? Simple. 4 plus 3 is 7. All right? So that means, okay, we will get 10 if I got what? The sum of 7 and 3. I'll get 13 if I get the sum of 10 and 3. And I'll get 16 if I get the sum of 13 and 3. So in other words, if you go to the next term, you will add 3, okay, by the previous term. So that means the common difference here is 3. That is your common difference. Okay? So if that's the case, then we are going to use arithmetic sequence formula. So this is a sub n is equal to a sub 1 plus quantity n minus 1 times d, your common difference. So, since you're asked to find the 20th term, therefore your n should be 20. So hence we will have a sub 20 is equal to, okay, a sub 1, so you have negative 2. A sub 1 is your first term, which is negative 2. Okay, plus quantity. Your n, once again, is 20, so this would be 20 minus 1 times your common difference, which is your 3. All right, so let's go. A sub 20 is equal to negative 2 plus 20 minus 1, you will have 19 times 3. So if you're going to multiply 19 by 3, you will have 57. Right? So adding negative 2 and 57 will give you 55. So that is your answer, 55. Okay? So that's it. Okay, that's how you basically get the n term if you have an infinite sequence here. Okay? So let's proceed to the third question. Suppose that the common difference is 10. First term is 3 and fifth term is 43. What will be the second term, the third term, the fourth term, and the fifth series? So let's write the given first. The given here is that we have a common difference of 10. Second, your first term is 3. Your fifth term, hold on. Your fifth term is 43. Okay? So, what will be the second term? So, you are asked to find the second term, which is a sub 2. The third term, or your a sub 3. Your fourth term, or your a sub 4. And the fifth series, s sub 5 or s5. Okay? So, when we say fifth series, it means the sum of the first 5 terms. Okay? The sum of the first 5 terms. Okay? Now, let's take a look. Let's rewrite them in arranged order. Okay? your first term is 3. Then your second term, blank. Third term, blank. Fourth term, blank. And the fifth term, we have 42. Okay. Here's the thing though. How will you find the second term, the third term, and the fourth term? You can use the formula. Okay? It's easy. So let's find a sub 2. A sub 2 is equal to a sub 1 plus, since your n is equal to 2, therefore it will be 2 minus 1 times b. Okay? Let's substitute. So a sub 1 is 3 plus 2 minus 1 is 1 times d, which is your 10. So you will have 3 plus 10. So it is equal to 13. So that is your second term, 13, right? Next, let's find your a sub 3. Okay, your a sub 3, okay, the same formula, a sub 1 plus, your n here is 3, so therefore this would be 3 minus 1 times d. So let's substitute. A sub 1, 3, 3 minus 1, 2, times d, 10. So you will have 3 plus 20, which is 23. So that is your answer. Your A3 is 23. Now lastly, A sub 4. So for A sub 4, A sub 1 plus 4 minus 1, D. So let's substitute. A sub 1 is 3 plus 4 minus 1 is 3 times D is your 10. So you will have 3 plus 30. So this is equal to 33. So that is your A sub 4. So see, that's it. It's easy. Okay? But actually, there's much easier method than using the formula. And you know what that is? The use of your head or your critical thinking. Okay? So, right, we have common difference of 10. Right? We have that. So, all I need to do is I'm just going to add them continuously. That's it. For example, 3. Okay. 3 plus 10, 13. Oh, that's it. That's your A sub 2. Oh, now next, 13. 13 plus 10, 23. Oh, that's your A sub 3. And next, 23 plus 10, 33. So that's it. That's your A sub 4. So that's it. There's no need for you to use the formula. All you need to do is to just simply add them. All right? 3 plus 10, 13. Oh, finish. That's the second term. Next, find the third term. Oh, it's simple. 13 plus 10, 23. Finish. Now, let's get the fourth term. Okay? 23 plus 10, 33. There you go. Finish. That's it. Okay? So, yeah. That's basically your missing terms in a sequence. Now, let's find your S sub 5 or the fifth series. So this one is easy. Why? All you need to do is to add them. All right? That's it. Just add them. So there are two ways. You can use the formula or just add them. Okay? Just add them. So you see, wait, since I have no space, I think it's better for me to write it. I think I'm going to erase this one since we've already know what is your A sub 2, A sub 3, and A sub 4. So I'm going to erase this one. All right. Let's go. Okay. Let's go here. So you can use the formula. The formula of the arithmetic sequence is Sn or S sub n is equal to n all over 2 times quantity a sub 1 plus a sub n. That's it. So if you're asking to find S5, then that means your n is equal to 5. Therefore, we will have S sub 5 is equal to 5 all over 2 times quantity a sub 1 is 3 plus your n here is 5. So we will have a sub 5. However, your a sub 5 is 43. Therefore, we can substitute a sub 5 as 43. Okay? Now, let's add them together. 5 all over 2 times 3 plus 43. Whoops, sorry. 46. That's it. 46. Now, if you use your calculator, it's actually easy, right? But if you want me to solve it manually, then I can do it slowly. Okay? 5 all over 2 times 46. I can actually simplify this one. 2 and 46. Okay? 2 and 46 are both divisible by 2. Okay, so I can simplify them both. Or, to make things short, okay, divide 46 by 2. Okay. Why is it that we can divide 46 by 2? Okay. So, first and foremost, if you're going to multiply a fraction and a term, you're going to multiply the term to the numerator only. So you will have, oh, sorry. So you have 46 all over 2. Okay. What do you call this one? Then you can divide 46 by 2 here. So 46 divided by 2, you will have 5 times 23. Because 46 divided by 2 is 23. So let's multiply. 5 times 23, you will have 150. So that's it. That is your final answer. Okay? Or, because you have only 5 terms, you can just simply add them. All right? You can just simply add them. So you will have 3 plus 13 plus 23 plus 33 plus 43. You can use your calculator or just manually add them. The result is 150. So therefore, your answer is 115. That's it. Okay? So this is your S5 or the fifth series. Okay. Now let's proceed here. Find the missing term of the, what do you call this one? Of the given geometric sequence. So how can we find this one? So since it is a geometric sequence, what is one thing that you need to remember if you have a geometric sequence? So for the arithmetic sequence, we have the common difference. For the geometric sequence, we have the ratio. You need to know the ratio of the geometric sequence. Okay? So that means what? That means you need to know your ratio. That's all. You need to find your ratio. So how do we know your ratio? Okay. All you need to do is to what? Observe the sequence. 12 and 48. How did we get 48 if the previous term is 12? It's simple. You multiply 12 by 4. So 12 times 4 is 48. Okay. Now, how about 192? If the previous term is 48, how did we get 192? We multiplied by 4. by 48. 48 times 4 is 192. Okay. So as you can see, if we proceed further and further and further, we will what? We will simply multiply the previous term by 4 just to get the next term. So that's it. Okay, that's how you get your next term. Okay, so that means your ratio is 4. That is your ratio. Okay, but if you're having a hard time, because instead of like for example multiplying, instead of guessing, well, there's one thing for you to determine the ratio in easy way. Get two consecutive terms, meaning two terms that are together. For example, 48 and 12. These two. Okay? Then after that, divide it together. So ratio is equal to 48 all over 12. So 48 divided by 12 is 4. That's it. Okay? How about this one? 100, 768 and 192. So this is 768 divided by 192. The answer is still 4. Okay. Now do that here as well. Okay. Your ratio is equal to 12,288 all over 3,072. The ratio here is 4. So that means your common ratio is 4. That's it. Okay. That's how you get your common ratio. If in case you are tired of guessing. Okay. So now that you have your common ratio of 4, let's now substitute it on the formula. The formula of the geometric sequence is a sub n is equal to a sub 1 times r raised to n minus 1. Okay. Now here's the thing. We need to determine your n. Okay. So by determining your n, you need to locate the missing term. So this is your first term, second term, third term, fourth term, fifth term, sixth term, and the seventh term. So that means your n is equal to 7. So you will have a sub 7 is equal to a sub 1 times r raised to 7 minus 1. That's it. Now let's substitute. Okay. Your a sub 1 or the first term is 12 times your r is your 4. Then 7 minus 1 is 6. That's it. So 4 raised to 6 is actually 4,096. So multiplied by 12, you will get the answer of 49,100 and 150. That is the missing term. Or if you don't want to write solution and such, if you want to use your head, then there's no problem, right? Once again, we get the next term by multiplying 4, right? For example, 48. Oh, how do we get 48? We multiply the previous term by 4. So 12 times 4, 48. So how about this one? 192. How did we get to 192? It's simple. You multiply the previous term by 4. So 48 times 4 is 192. So therefore, if this is the missing term and this is your previous term, so 4 times 12,228. So the answer is what? 4 times 12,288. The answer is 49,150. So if you knew the pattern, you do not need the formula. All you need to do is to use your head. See? Now how about this one? find the series of this given sequence. So as you can see, this is actually a finite sequence or finite sequence because this is an example of the sequence that has an ending term. The ending term of this sequence is 1701. Okay, so let's find the series. So this one is easy. Since there are only like 6 terms, you can just get your calculator and add them. It's easy. Okay, but if you want to use the formula, there's no problem. However, if you want to know what formula or which formula you're going to use, then you need to observe the pattern before you're going to, once again, find the series. So we have 7 and 21. How did we get 21 if the first term or the previous term before 21 is 7? We simply multiply 7 by 3. So 3 times 7 is 21. So we have 63 here. So 63 and 21. How did we get 63 if we have 21? Okay. So we simply multiply 21 by 3. 21 times 3 is 61. So therefore, if you want to get the next term, just multiply the previous term by 3. So as a result, this is what? A geometric sequence because there is a common ratio of 3. Or if you're having a hard time to get your common ratio, what to do? Just get 2 consecutive terms or 2 terms that are stick together. For example, 63 and 21. So divide them both. 63 divided by 21, you will have 3. All right. 189 all over 63. Okay. If you're going to divide them together, you will have the result of 3. Therefore, your common ratio is 3. That's it, right? That's how you get your common ratio, if and only if you are having a hard time. All right? So, by the way, before I proceed, make sure that all the common ratios are the same. If not, then that's a different sequence already. Okay? Okay. So let's go. So since we know that it is a geometric sequence, what would be the formula of the geometric series? The formula is f sub n is equal to a sub 1 times quantity 1 minus r raised to n all over 1 minus r. So, what would be the given here? All right. So once again, here's the formula of the geometric series. Okay. So now, first we need to find your n. Okay, n is very important here. So first, how many terms are given? Because right, we're going to find the series of the given sequence. So meaning all of them. We're going to add all of them. So how many are them? So 1, 2, 3, 4, 5, and 6. Therefore, your n is equal to 6. So you will have s sub 6 is equal to a sub 1. Your a sub 1 is your what? Your 7. So this is 7 times quantity 1 minus your r, which is 3, raised to n, which is your 6, all over 1 minus 3. That's it. Now, let's simplify. So 7 times quantity 1 minus your 3 raised to 6 is exactly 729. And here, 1 minus 3 is negative. Okay. Now, if you're going to subtract 1 and 729, you will have negative 728 all over negative 2. Okay. So, if you're going to use your calculator or if you're going to uh, solve it manually, The answer for this one, negative 728. Okay. The answer wait, hold on, I'm actually wrong. Okay. The answer for this one is 2,549. Okay, that's the answer. So let's try to solve it manually so that you will have the idea of what I mean. Okay. First, I can divide what is this one? Divide negative 728 by negative 2. So if I'm going to divide them both, I will have 7 times 7 times positive 364. So multiply 364 and 7, you will have 2,548. Forgive me, it's actually 2,548. I'm actually wrong. Forgive me. This is the correct answer. All right. So yep, 7 times negative 729 over. Yep. Okay. This is the correct answer. Okay. Forgive me. It's 2,540. Or guys, since there are just only like 6 terms, you can just add them. There's no need for you to use the formula. Just add them. Just use your calculator or your notes or paper, then pen, and just manually add them. You will also get the same answer. All right. So yeah, where was I? Let's proceed to the 6th question. Find the series of this given sequence. As you can see, oh sorry. So as you can see, here we have 5, 10, 20, 40, 80, 160, 320. Okay. So you're asked to find the series of this given sequence. So meaning all of these. So here's the thing. You see the 3 dots here? You see the 3 dots here? It means it is an infinite. It is an infinite sequence. Oops, hold on. There we go. So as you can see, it is an infinite sequence. Then how will you add them? Right? How? Because it's infinite. It's continuously proceeding, like it continuously evolving. So how will you get the sum of an infinite sequence? First, take a look at the pattern. As usual, look at the pattern. You have 5, 10, 20, 40, 80. So how do we get 10 if the previous term is 5? We simply multiplied by 2. 5 times 2 is 10. Now, if we have 20 and we have 10, so how did we get 20? Simple. We multiply 10 by 2. So 10 times 2 is 20. And here we have 40. So here, how did we get 40 if we have 20? So we just multiply 20 by 2. So 20 times 2 is 40. Okay? So that means this is what? A geometric sequence. Okay? This is obviously a geometric sequence. So you have a common ratio of 2. Okay? And if you're having a hard time, what to do if you don't know the common ratio, all you need to do is just get 2 consecutive terms, then divide them. For example, like this. Okay? 80 divided by 40 is what? 2, right? Or you can divide 40 by 20. 40 divided by 20 is 2, right? Or you can divide 320 by 160. 320 divided by 160 is 2. Therefore, your common ratio is 2. Okay? So what would be the formula you're going to use? The formula you're going to use is this one. S sub n, I'm sorry, S sub infinity is equal to A sub 1 all over 1 minus R. This is the formula if you have an infinite geometric sequence and yet you are asked to find the geometric series for an infinite geometric sequence. Okay? So once again, if you have an infinite geometric sequence, okay? And then you want to find the sum of all the terms, like all of them, like all of the terms in that infinite sequence, then you are going to use this formula. Okay? Okay. Let me repeat once again. If you are asked to find the series of the infinite geometric sequence, meaning all of them, all the terms, like all of them, then you're going to use this one. Okay? If it's only infinite, okay? So let's substitute. So your a sub 1 is obviously 5 all over 1 minus your r is 2. So you have 5 all over negative 1. So 5 divided by negative 1 will give you negative 5. So that means in this infinite sequence, as you add them thoroughly, like continuously, and all of them, you will get the sum of negative 5. Okay, so it's like 5 plus 10 plus 20 plus 40 plus 80 plus yada 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 is equal to negative 5. So that is your answer. Okay, you may not believe me because it's addition, right? So you're going to add all of them. So why was there a negative answer at the end? Okay, so that is actually more of an in-depth of explanation, which I highly suggest you to search it in Google or in internet website. Okay, so let's go. Now here in 7, here I'm going to write the given here. Okay, let's just say you have a given of a sub 1, which is your, what do you call it, which is 33. Okay, then your a sub n is equal to 121. Okay, and then your n is equal to, let's just say 12. Okay, what would be the common difference? Again, you have a sub 1, you have a sub n, you have n is equal to 12. What would be your common difference? So since you are asked to find the common difference, what would be the formula you're going to use? You're going to use arithmetic sequence. So this would be a sub n is equal to a sub 1 plus n minus 1 times d. Your a sub n here is 121 is equal to a sub 1, 33, plus your n here is 12 minus 11. 11. Forgive me. No. Sorry. It's 1. Sorry. Times b. So here we will have 121, 33 plus 12 minus 1 is 11. Okay. Now let's transpose 33 to the left side. We will have 121 minus 33 is equal to 11b. So let's subtract. 121 minus 33 will give you exactly 88. Okay, is equal to 11b. Now to find your d, divide both sides by 11. So you will have 8 is equal to b. This is your common difference. Okay, that's how you find your common difference. Okay, next. Let's just say you have a given of a sub 1, which is your 3. your a sub n, this is your, what do you call this one? This is 81. Okay. And then your n is equal to, let's just say 3. Okay. No. It's actually 4. Sorry. It's actually 4. Now, how will you find your ratio or common ratio? Again, you're given here is that you have a sub 1 is equal to 3. You have a sub n is equal to 81. Your n is equal to 4. Now, how will you find your common ratio? So since you're asked to find the common ratio, then you are going to use the formula of a sub n is equal to a sub 1 times r raised to n minus 1. You're going to use this formula. So let's substitute. A sub n is 81 is equal to a sub 1 is 3 times r raised to n, which is 4, minus 1. So you will have 81 is equal to 3r raised to 4 minus 1. Now, to get, what is this one? Now, you need to divide both sides by 3. So, divide both sides by 3. I think this is 27, if I'm correct. Yep, I'm correct. So, divide both sides by 3. You will have 27 is equal to r cubed. And since we are asked to find the r only, then you're going to cube root both sides. Okay. So by doing so, we will cube root both sides. Okay. So what is the cube root of 27? Wait, let me fix that equation. Wait. Is equal to r cubed. So let's cube root both sides. Okay. So the cube root of 27 is 3. And this one will become r. Why is it that we need to cube root both sides? Okay, we need to cube root both sides so that we can cancel the exponent 3. Okay, for example, 81 is equal to r squared. So if ever using exponent, automatically you will square root. Okay, why is it that we're going to square root? So that we're going to cancel the exponent of 2. Okay, so why is it that square rooting will cancel the exponent 2? Because square root of r squared is equal to r squared raised to 1/2. And by the definition of law of exponents, multiply 2 and 1/2, you will have r, hold on, r raised to 1. So you will have r. So the same thing here, okay, the same thing here. So if you have r cubed, if you want to remove your 3 on the exponent, you're going to cube root. So the cube root is just the same as r raised to 3 raised to 1/3. So multiply these two exponents, you will have r as a result. Hold on. You will only have r as a result. Okay? That is why if you're going to find your r only and you have r cubed, so you're going to cube root both sides. Okay? So that's it. So the answer here is 3. Your common ratio here is 3. All right? So we're good to go. Okay. Then next, here we have, what I call this one? No, actually this is wrong. This is another question here. This is actually wrong, forgive me. So, how about this one? Question number 10, which is the last problem. You have a 30th, you have a 30th term of 500. Then you have a common difference of 3. and yet you are asked to find a sub 1 and the 30th series, or the sum of the first 30 terms. So how are we going to do that? First, let's find your a sub 1. Okay, let's find this one. Okay, so first, we're going to use the formula a sub n is equal to a sub 1 plus quantity 1 minus 1 times d. Since we have a sub 30 as your 500, therefore, your n is equal to 30. So we will have a sub 30 is equal to a sub 1 plus quantity 30 minus 1. Now let's substitute. Your a sub 30 is 500 is equal to your a sub 1 is still missing, plus 30 minus 1 is 29, and your d is 3. So times 3. So 500 is equal to a sub 1 plus 29 times 3, you will have 87. So to get your a sub 1, transpose 87 to the left, you will have 500 minus 87 is equal to 81. So 500 minus 87 will give you exactly 413 is equal to a sub 1. Okay, so we're done. Now we need to find your 30th series, or the sum of the first 30 terms. So what's the formula? The formula is S sub n is equal to n all over 2 times a sub 1 plus a sub n. Since we are asked to find the 30th series, therefore your n is obviously equal to 30. So you will have S sub 30 is equal to 30 all over 2 times quantity a sub 1, okay, plus a sub n, or sorry, a sub 30, because your n is equal to 30. So therefore it's a sub 30. Okay. So again, from a sub n to a sub 30, why did it become a sub 30? It's because your n is equal to 30. Therefore, it will become a sub 30 instead. So now let's substitute. 30 divided by 2 is 15. Times quantity, a sub 1 is 413. Plus, your a sub 30 is 500. Okay. So, by adding them together, you will have 15 times quantity, 930. Okay. So, by doing so, multiply it by 15, you will have your final answer of 13,695. So that is your S sub 30. So that's it, guys. That's all the problems that I can give. I hope you have learned something. So that is all. Thank you once again.